Hello everyone, welcome back to my channel. Today we will be talking about an important topic, K-map. K-map, which is done by a scientist Carnot, was a graphical plot used to minimize Boolean algebra. Whenever we are trying to solve any Boolean expression, what we use Boolean algebra. When I say Boolean algebra, there are many identities of Boolean algebra. So everybody will solve that expression by applying his own set of identities, and somewhere we couldn't get one concrete answer for the same, due to which your minimization using Boolean expressions was replaced by K-map. When I say K-map is a simplification method where we'll be either using min-terms or we'll be using max terms. Let's quickly talk about min-terms and max terms. When I say min-terms, what I am talking about? I am talking about an SOP form. When I say SOP form stands for sum of product. When I say sum of product, they are those terms in the truth table where your output is high. Wherever in the truth table your output is high, all those terms are called min terms, and they can be written in SOP form. Similarly, max terms are a part of POS form, and they are all terms in the truth table where your output is low. Now I'll quickly tell you the points which are used to plot a K-map. When I say K-map, there are few rules and regulations for working on K-map. Now, very first thing is K-map is dependent upon input variables. When I say input variables, normally you are given an expression. Let us say it is summation f. Let it be as f is equal to f of a, b is equal to summation m 0, 2. Now, in this, what we come to know, we are being given two variables, 2 raised to power 2. How many cell K-map it will be? 4 cell. If it is 3 variable, 2 raised to power 3, 8 cells. That means you will keep in mind the journal formula. If it is n variables, your cell size of K-map will be 2 raised to power n cells. Right. Now, after you make or plot the K-map with respect to the given size, what you will do, you will put either SOP min terms or max terms in the plot, and then you will group them. While grouping, somewhere groups will be made in octet, pair, octet, then quad, then pair, and then single. Fourth, somewhere do keep in mind, while you are grouping, diagonal grouping is not allowed. Diagonal group formation is not allowed. And while minimization, do keep in mind only the variable which doesn't change is considered. Right. Now, let's start with a small K-map example. Let us have an expression f of a, b, c is equal to summation m 1, 3, 6, 7. Now, when we are talking about 3 variables, it will tell us the cell size of K-map, 2 raised to power 3, 8 cells. Now, 8 cells, let us make first the K-map plot. A, B, C. Now A can be 0, A can be 1. When we are talking about two values BC, BC can be 0, 0, 0, 1, 1, 0, 1, 1. This is the binary representation. But do keep in mind, in K-maps we use gray codes. So if you will convert each of these binary into equivalent gray codes, somewhere the value is what? 0, 0, 0, 1, 1, 1, 1, 0. Now let's name them. Somewhere 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, 0, 1, 0, 1, 1, 1, 1, 1, 0. How I'm numbering it? I will just explain it. Somewhere 0, this cell has first bit as A, 0. Next two bits are B and C. B and C are also 0, 0. So the number became as 1, 1, 3 times 0. Similarly, talk about this cell. Here A is what? 1. Talk about BC. BC is what? 0, 1. So cell name is what? 1, 0, 1. So this is how you are supposed to name your cells. Let's quickly make the table back. Now, if I go by the values, this is 0, 1, 2, 3, 4, 5, 6, 7. What I have done, I have written the decimal equivalent of the given binary numbers in the cell. Now, next step for this is, now after we have made the K-map, we'll plot the minterms. Now minterm is high at 1, minterm is high at 3, minterm is high at 6, minterm is high at 7. Now, as per rules, we have 4 ones, but these 4 ones are not available in one group. So somewhere we'll focus on pair. When I say pair, one pair which is possible is this. Second pair which is possible is this. Third pair which you can think upon is this. But do keep in mind, we will avoid redundancy. So this will have only 2 pairs as shown in the diagram. Now once we have finalized the pair, we will make the group. Talk about the group made with yellow color. Somewhere value of A is what? A is 0. How do I write A? I'll write A as A bar. Then focus yourself on B. When I say B, is B same? In first cell B is 0, in second cell B is 1. So B is not same. Talk about C. Is C same? In first cell C is 1, in second cell C is again 1. Somewhere C is same and C is having numerical value as 1. So the value of first yellow color cell will be A bar plus C. Plus talk about the other cell. Here value of A is what? A is 1. So how do we write 1? In SOP we write it as without bar, that is A. Talk about other two terms B and C. Compare B. Is B 1? Yes, B is 1 in both the cases. That means B is constant. So I'll be using B as it is. Talk about C. Is C same? No, C is not same. So what will be the answer of this K-map? It will be A bar C plus AB. Right? The thing which we will keep in mind is somewhere we can see one more pair, the one which is done with a light blue color, but this will not be considered. Why? This is a redundant group. Redundant means repeated group, and if the ones which we are considering are already paired, we will not be using or repeat the group. Why? Somewhere again we are increasing the number of variables or we are trying to reduce the redundant bits. I'll be coming with more examples on KMap in upcoming videos. That's all for